this speeding, the TWAS was established in around 1985 by a group of scientists led by Professor Abdul Salam, a Nobel laureate from Pakistan. And then it was formally inaugurated in 1986 by the then Secretary General of UNESCO. Its mission being to promote scientific capacity and excellence and for sustainable development of the South. TWAS has many activities in its fold, and it has extensive collaboration and cooperation with the Inter-Academy Panel, Inter-Academy Medical Panel, AAAS, American Advancement Science, and then Sustainable Center at Cambridge, and many other things. It recognizes senior scientists working in the South with a fellowship. It also selects TWAS young affiliates annually throughout the South. In order to do many of its activities, the TWAS has established 5 regional centers covering the entire South, South American and Caribbean, Sub-Saharan African, Arab region, the Central and South Asian region, located at the Jawaharlal Nehru Center for Advanced Scientific Research. That's what we are holding the meeting. And then South Asia and Pacific, East Asia and Pacific. So these 5 centers carry out large number of activities to promote youngsters, young scientists, to have an extensive collaboration between the countries and between the regions to promote science and sustainable development. The UNESCO has been supporting these activities for long, ever since its inception. And a few years ago, the Italian Parliament has permanent funding mechanism to support all the activities of TWAS. Now, among the many activities, I think one such is the holding of the meetings of the regional offices, especially for young scientists, to have mutual interaction, establish strong contacts, and build up networks in these regions. I hope this meeting will be one of those platforms, and wherein the young scientists interact with senior scientists and also among themselves to build up a viable network so that it contributes for sustainable development, especially the goals defined in the sustainability development goals. Thank you very much, and I hope you have a good meeting, and I will be with you all along, listening to the talks and listening to the interaction of young people. Thank you very much.
Thank you, sir. I will also quickly introduce Professor Satish, who many participants here already know very well, but Professor Satish is the chair of the Divecha Center for Climate Change, who is co-organizing this event. He's a professor at the Center for Atmospheric and Oceanic Sciences at the Indian Institute of Science. He's also currently the Dean of, I believe it's Infrastructure and
Planning.
Sorry, sir. The Dean of Infrastructure and Planning at the Indian Institute of Science. And he's also the Director of Future Earth Global Secretariat Hub, South Asia. Very similar to Professor V. Krishnan, he's also an elected fellow of 3 major Indian science academies. So the Indian Academy of Sciences, Indian National Science Academy, as well as the National Academy of Sciences in India, and also the World Academy of Sciences. And I am not going to go into too much detail about his various accomplishments, and I will allow Professor Satish to give his opening remarks for today's event.
Thank you. Thank you. Good morning and good afternoon to all. Once again, a warm welcome to this Young Scientists meeting on air quality, water resources, energy and climate change, organized by the World Academy of Sciences, Central and South Asia region partner, and the Deveja Center for Climate Change at IISc Bangalore. I would like to say very briefly about the center, that is the Deveja Center for Climate Change. The Deveja Center for Climate Change was established at Indian Institute of Science in 2009 with the financial support from Arjun and Diana Deveja and the Grandam Foundation for the Protection of the Environment. During the 1 decade since it was established, the center has been involved in interlinking science and policy for a sustainable development. And since its inception, the center received generous support from various ministries and departments of Government of India. And in addition to research, we also conduct training programs and workshops to create awareness among young researchers about climate change. This event is an example. The objective of this meeting is to provide a platform for young scientists to improve their understanding on topics related to climate change. And this meeting also offers unique opportunity for networking among young researchers. I wish you all a very fruitful meeting ahead. Thank you. Anupama, maybe I request Professor Dr. Parmesh to start the session, please.
Yes, sir. Thank you. Screen share model.
Sorry, I just gotten disconnected for just 10 seconds. Dr. Parmesh, please allow me to introduce you before you.
Yes, okay.
Yes, just. All right. So sorry. So yes, Dr. Parmesh is retired Professor Dr. Parmesh, who is actually a medical doctor, is a pediatric pulmonologist and an environmentalist. He is the founding member and past chairperson of the respiratory chapter of the Indian Academy of Pediatrics, the founder life patron of the respiratory chapter of Karnataka, the founder president of the Indian Medical Association of Bangalore East, and he's also the founder member and advisor of the Thalassemia Society of Bangalore. He is the past national president of the Indian Academy of Allergy and a past national president of the Pediatric Association of India. He's currently a visiting professor at the Deveja Center for Climate Change, Indian Institute of Science, and he's also a visiting professor in various universities and countries in and outside India, including USA, Canada, Italy, Nepal, and the UK. He's a member of the WHO NGO Climate Health Working Group Geneva and is an advisor to the WHO, UNICEF, ComHAD, and Alliance for Global Health. Thank you so much, Dr. Parmesh, for agreeing to speak at our event today. Please.
Yes, sir. Thank you very much, Anupama, for a kind introduction in the presence of our chairman and Professor Satish and our senior professor, Professor V. Krishnan, and distinguished participants. I think it is a meeting of the young technology scientists, Orient scientists, and also the wisdom from the senior scientist combination. I think we learn each other, enhance our self-knowledge for the future life sustainability in the world. The topic I'm going to cover is on the impact of the air pollution, climate change, and health. I think Professor V. Krishnan, during his address, he did mention that science for sustainable development. Yes, WHO mentioned about for sustainable development goals, it started 2015 up till 2030. And for the survival of, they have done about 17 items. In the 17 items, 16 of them mainly directly, indirectly, or related to health only. And among the important things for the survival of life, 3 important things been highlighted. One is the air, what we breathe in. And second is the water, potable water, what we drink. And next is the nutritious food. As a matter, we need about 2 to 3 liters of air per day to drink. Potable water, 2 liters of water. And also the food, we need about 1.5 to 2 kg of food, as a matter of fact. And all these 2 things gives only survival of for energy for about 10%. I think it is the air, as a matter of fact, the most important. So how much air we need? Air we need is we need about 500 liters of oxygen at a quiet, simple, quiet, without activity in the home. To get that 500 liters of air, we have to breathe 10,000 liters of air to get that oxygen, 10,000 liters of air. And heart has to pump 10,000 liters of blood to get the oxygen from the lungs. So we are all aware of it, and also has been published and written up in textbooks. You cannot survive without breathing more than 3 minutes, without drinking water more than 3 days, without eating food for 3 weeks. As a matter of fact, having learned this one, the importance of oxygen, air what we breathe in, is the most paramount important. Let us focus on that one. As we are aware that air pollution, global warming, climate change, they're all interrelated. All the scientists are agree about now, as a matter of fact. There's no question about it. When the temperature rises, the air pollution, all sea level rises, a precipitation happens, ice peaks are melting, whole lot of things. And they have the impact on the health, directly, indirectly, and also why it is have some problem. Go back. Now, so agriculture, the yield going to be decreased and protein content going to be less, and also water resources going to water-related diseases, a lot of them going to come on contamination from the germs and the chemicals, and coastal erosion leading to the definitely migration of the people, diseases, you name it, as a matter of drowning and a whole lot of other things. And species and natural areas will decrease, as a matter of fact, loss of habitat will happen. I think it has been anthropo changes causing irreversible damage. If you look at that one, the previous 65 million years, 1 species out of billion species per year were extinct. Nowadays, nearly 1,000 species per million species per year are extinct, and nearly 22 to 47% of the plants are endangered. So it is very essential for us to pay attention. And now it is urgent, now it is an emergent issue has come now. Now, what is the source of air pollution? Air pollution has earlier, there was air pollution also, and the carbon emission there also there, it is also now. Earlier, it was mainly from the volcanic eruptions. And second thing is the human and animal breathing. Third is from the decayed material. Fourth is from the natural forest fires which used to occur. These are all the 4 things were there earlier. Nowadays, in addition to that, 5 more added. They are the deforestation to accommodate the industries, deforestation, industrialization, rapid urbanization, and also traffic as a matter. And the transport contributes significantly their emissions with the fossil fuel, and also to support the non-vegetarian, the animal farming has increased. So that's all the 5 more things have been added. If you look at the carbon dioxide earlier, from the year 1000, it was only 150 to 200 was there. So in the mid-industrial area, it is 1800 onwards, definitely it has gone. So, hello?
Sorry, sir, your screen is not visible anymore.
Yeah. So screen is not suddenly went up. Okay.
All good, sir, now.
Okay, thank you. So this is what it happened as a matter of fact. And let's move forward. It was now after the industrialization, carbon dioxide definitely picking up as a matter of fact. This has been identified ice cores where the carbon particles have been deposited. Okay. I think air pollution kills nearly 6.5 million people every single year. If you look at the various other countries, India comes number 1, next comes China. I think 70% of the diseases caused by the environmental pollution are non-communicable diseases. In them, 70% of the non-communicable diseases are from the air pollution. Nearly in Asia, it has been appreciated mainly from the air pollution. 79,16,000 premature deaths occurs in Asia. In that, 24,60,000 premature deaths occur in India mainly from the fossil fuel, only identified. These are all the values. Air pollution predominant, then water comes and various other chemicals will come. And now, air pollution has an impact from womb to tomb. No doubt, genetics is a brick and mortar, but environment is an architect to bring out the various diseases, including allergic diseases. The air pollution, agriculture, food, and microbiota contribute early immune development in the fetus by epigenetic changes, which has a lasting effect in the child's life in future, as a matter. In that one, air pollution contributed significantly for the changes in the development, allergic diseases and the infection, respiratory infection. The good food and microbiota living in the farmhouse, old atmosphere with animals, pets, and all this thing, that is more beneficial, as a matter of fact. Now, how does these various pollutants are there? Various pollutants we have the particulate matter and we have the gases. Particulate matter, the worst variety as a matter of fact, 2.5 micron, so the fine particle has a 3% the size of the hair. It is the mixture of the solid and liquid floating in the air, and 10 micron, it travels 10 yards to 30 miles. 2.5 micron can travel many hundred miles. It has got various components is listed here: sulfate, nitrate, ammonia, a whole lot of things. And bigger particle deposit predominantly upper respiratory tract, and smaller medium-sized particle is the 2.25 micron. They deposit in the central airways, and small particle deposit in the small airways and alveolar air sac. And 2.5 micron, even radioisotope studies have shown, if you inhale that, within a minute, they enter the bloodstream. And circulate all over the body, producing various damages in vital organ. But the lungs are the greatest, having the greatest impact in those diseases. And the gases is water soluble, predominantly upper respiratory, less soluble ozone is mainly the central airways, and the least soluble oxygen, nitrogen, mainly in the periphery. The traffic derived air pollution, when the pregnant mother been exposed, what will happen to their fetus has been studied as a matter of fact. I think definitely if you inhale small particle, when from the lungs enter the bloodstream, there the inflammation of the mucous membrane happens, aggregation of platelet happens, small clots will be formed. These clots circulate and deposit in the placenta. That decreases nutrition of the fetus, what mother is carrying. So if the pollution clots are too many, there is stillbirth going to happen. If it is less, prematurity will happen. If it is still less, small for date babies. Even the baby mother carries up to 9 months, their baby will be premature. And that produces what we call fixed airway obstruction. Their lung capacity, airway always less, lifelong. And these are all the people suffer lifelong. And they are the people suffer most of the asthma, wheezing, and all this thing. And they need constant medication lifelong. And if you don't manage, they are the true people develop airway remodeling in future, chronic COPD, what we call. The antenatal exposure synergized with the postnatal exposure with increase in susceptibility to the development of bronchiolitis, inflammation in the small bronchial tube, asthma, and wheeze. So air pollution definitely is preventable. When we say wheeze, wheeze has gone up all over the world. I think in the year 2017, Lancet editorial board, and they got the opinion of the global experts' opinion, 8 of them. I'm representing Indian subcontinent. They asked me, I said, yes, wheezing has definitely increased in our country also, our neighboring country, where we have nearly 77.5% of the children under 5 years are the wheezers. In them, 26.3% less than 1 year. And any wheeze and bronchodilator, we recommend use the bronchodilator until you found out the cause for this specific treatment. And studies our own friend has done in Pollen, it shows if the 2.5 micron increase from 35.5 micron to 53.4 micron, there is 4-fold increase in the wheezing in these children. And definitely, these are all the issues we have to keep it in mind. I think these air pollution primarily impact on the lungs, respiratory system. As I said, upper respiratory tract, you have the nose, sinuses, conjunctiva, and all this thing. You have inflammation, infection will come there. Sinusitis, middle ear infection. And lower respiratory tract, below the thoracic inlet is the lower respiratory tract. There you produce laryngitis, bronchitis, tracheitis, and asthma, and COPD, chronic obstructive pulmonary disease. And in the parenchyma, lung substance with the gas exchange occurs, there you develop pneumonia, interstitial fibrosis between the, because from lung to the blood, there are 7 layers. They will become thicker. That is called interstitium because scar formation, oxygen demand increase. And that has produced, because nose block and all this thing, sleep disorder breathing is produced, and chronic cough is a major contributing factor. And also it does produce spinal health because of obstructive airway problem, your shoulder will go up, you get angulate, you bend forward, that you've got a hunchback, spinal problem. These people in the middle of their age, they suffer most. Always, airway allergies are the global epidemic with significant psycho-socio-economic burden. WHO says 2015, there was about 1 billion people are suffering. 2050, they say 4 billion population around the world going to suffer from the allergic disease and asthma. That's a major psycho-socio-economic burden. And let's see some of the data what we have. The allergic diseases are the earliest onset non-communicable diseases. In allergic rhinitis, in 1994 in Bangalore is 22.5%. Now 2004, it has gone up to 40%. Now it's up to 50 to 60%. In a general pediatric population. In the allergic people who got allergy, they had 1999 to 75%, gone up to 99.9% in 2011. 100% of the people, they have allergic rhinitis. And they have other comorbid middle ear infection, sinusitis, you name it. And asthma. 48.
Yeah, I'm not able to hear anything.
It was 9% and it's steadily gone up in 2 decades to 29.5%. Then it is stabilized. Small peaks here and there is going around. Now, I think in the third decade, 25.5, currently in 2016 is the 28%. Why it is? Because the earlier thing was the change in the demography of the city of Bangalore, air pollution was the main contributing factor. Why it is stabilized at that time, that's mainly saturation of genetically exposed population. However, they continue to export, that leads to the persistent asthma where they need constant medication. That has gone up to nearly to 20% to 72.5%. But it's persistent severe asthma where not only need constant medication and higher dose, and their visit is much more often in the hospitalization, mortality much higher in them, that has gone up to 4% to 11%. I think this is the situation as a matter of fact. And chronic cough, the most common cause chronic cough is the allergic disease. Once you inhale the air, the polluted air for 1 hour, it takes about 4 weeks biochemically and anatomically heal. Beyond the human studies, human volunteers. The chronic cough, most common cause is respiratory allergy. Earlier it was lower respiratory, now it is an upper respiratory allergy. In 1999 is 8%, in 2017 is 21.25%. And every year there's 0.5% in the chronic coughing more than 2 weeks without any infection. And these people have sleep disorder breathing. That is what sleep disorder breathing, the snoring. Normal population, children of adults, about 8% population, they snore in the night. Here is sleep disorder breathing, the 42% are the snorer, their mouth breather 43%, and eye conjunctivitis, allergic related is 27.5%, and grinding the teeth at night time, nearly about 17%, and laryngeal dyskinesia, suddenly the voice box comes closer. And that being produced, it's called laryngeal dyskinesia. When you inhale, it comes closer instead of opening. That has been treated like asthma. That has been increasing more often from the pollution, as a matter of fact. So how does the air inflammation produces? It produces from the oxidative stress. It is an imbalance. We don't have enough antioxidant. Oxidative stress produces. That leads to smooth muscle contraction, narrowing of the airways, fluid, blood vessels dilate, fluid leakage, it happens. And the receptors for the medication, beta receptor, they don't work effectively. And mucus gland will be there, they put excessive mucus. Normally we put 1 liter of mucus every single day, 600 to 700 ml from the nose and sinus, 200, 300 comes from the lungs. The mucus from the lungs has to move upwards, mucus from nose has to go backwards. It works from the cilia. The cilia also don't work with the air pollution. That's the most dangerous as a matter of fact. And altered, the release of the chemical mediators will happen. Okay. All right. Okay. Okay. Now, I think air pollution is an invisible killer. Nearly 43% of people have got chronic lung diseases, asthma and COPD, and 29% have got lung cancer, 25% have the heart attack, 24% have got the stroke. So after lung diseases, let's move to the non-pulmonary diseases. So there is increased cardiovascular diseases and increased blood pressure. Stroke will be more, cancer will be more, and also endocrinal, the insulin-resistant diabetes will be more from the air pollution, and obesity related to that. And now they say it is baldness also related to the air pollution. Now it affects the central nervous system by producing anosmia, loss of smell, autism, Alzheimer's disease, dementia, cognitive performance decrease, recurrent headache, like migraine headache in 12.9%. Recently, it's been identified in Hong Kong. And people who are living in the heavy polluted atmosphere. And behavior problem in the polluted day is higher. There is increased crime rate when the pollution is high, and also impaired judgment, and worst test scores in a polluted. If the students, smart students have taken polluted atmosphere in an exam, their score will be 10% less. Unlike if a day is a less polluted day. And reduced productivity of life is also will be there. And relating the kidney diseases, because global warming, what happens? You sweat more, you work more, and if you keep on drinking the fructose-related soft drinks, whole lot of things, that increase the osmolality and damages the kidney. As a matter, because the global warming, kidney disease is becoming more and more, almost 10% more than earlier, as a matter of fact. And what happens, what we have been doing is dialysis. Dialysis is an energy consuming, water consuming process. I think you have to dialyze 3 times a week for sustain of these life for these people. So they produce 7 times more carbon footprint. So I think we have to find some other way. And noise pollution is a part and parcel of the air pollution. It has got tremendous ill effect. Indian cities rank the high on noise pollution, where we find high frequency deafness in newborns and also prematurity, intrauterine growth retardation, sleep disturbance, annoyance, headache, and decrease in the work efficiency, poor school performance. And these are all the things we have seen with the noise pollution. And coming to the life existent is at stake at Earth. It is an emergent factor and is a catastrophe situation. If we continue to contribute to the carbon dioxide, what we are having now, 4 to 500 further, we are going to irreversible damage to the lives on this planet. And if we further increase more than 600 part million, the extinction of no life is existent on this earth. We have to, that's how we have to maintain the carbon dioxide 250 part per million, and temperature should not rise more than 1.5 centigrade by end of this century. And what is the contributing factor for this carbon dioxide? What we breathe is 0.04%. How in the world has been many people, many of the scientists never believed it. 84% of the global warming coming from the carbon dioxide. Methane is only 9%. Nitrous oxide is only 5%. And fluorinated gas only 2%. So carbon dioxide, what we breathe out, the ocean absorbs them, 80% of them, which takes about 20 to 200 years. And 20% of carbon dioxide left behind, it takes 1,000 years. And the nitrous oxide, and definitely it 114 years. And methane is only about 14 years. Now, which are all the sectors producing? I think the industry is the number 1, agriculture related industry number 2 sector, and transport number 4 sector, and construction and all the things. This is the 5th sector. These are all the sector contributing significantly, and health sector contribute 4.4% of the carbon dioxide footprint. The most common cause for the pollution, air pollution, 95% is from the fossil fuel, coal and petrol and diesel. Only 1% comes from the burning of the waste and burning of the agricultural waste. This is what Delhi is facing now. This is the season. And 3% come from the cement. Fossil fuel kills. Clean energy saves life. We have to work on this aspect to reduce the carbon dioxide footprint. And who are all producing more of these fossil utilize of fossil fuel? China is nearly 28%, America 14%, and India is 6.8%. And how do you, so every country has to contribute according to what we all agreed upon in the Paris Accord. What we can do ourselves, how to mitigate the air pollution? By 3 ways: by quality education of all the stakeholders, by reducing the pollution further, and eliminate the existing pollutant. Normally, we produce about 3 billion tons per year carbon dioxide. That Mother Nature can handle. But we produce 9 billion tons, where Mother Earth cannot handle. So the existent from the Indian industrialization earlier, the people, Western countries, American country industrialized, their economic growth, they contributed nearly 2,400 billion tons. Who is going to pay for that? This is what issues. And there are technology-wise money is needed. That you have to look for that, how to tackle that. And people who are already affected, definitely we have to encourage them how to safeguard themselves good health by traditional food habits, good cross-ventilated house, and also we have to find a good medication for controlling anything, enhance the activity, the ciliary activity. Having learned that, so I think we have to, the health sector already educated itself. I think the WHO and Mason University in New York, we did a study. Indian Academy of Pediatrics, the first professional organization, have been signed in that one. It has been published, and we have nearly 98% of the pediatrics across the country. They are aware air pollution impact on that one. Each one of us are talking environmental chapter and all things. It has been published in the Lancet also. The other sector we have to do the water related issue, agriculture, energy, and industry, and so transport, whole lot of other 8 sectors we have to educate. Now, all right, we have guiding there, international what people has to do, nationally what we have to do it, what you can do yourself, what we can do ourselves, that we have to learn about this one. I think there are 10 items what we can do ourselves. As I said, carbon dioxide average, we produce about 4 tons per person. United States produce 16 tons per person. We want to keep the temperature carbon dioxide. We have to reduce to 2 tons per person. It's an emergency measure we have to do. How do we do it? We'll go. If you don't have any car, you can save up 2 tons of carbon footprint per year. If you use electrical car, you can save 1.95 ton per year. And if you long haul, if you stop 1 hour, long flight from Bangalore to London, you can save 1 ton of carbon dioxide per person. And renewable energy, if you use from the solar and other energy, you can save 1.68 ton per year. And public transport, small places, you walk around wherever it is, and also use the bicycle. If you avoid small things, use bus if you are going anywhere, metro, train. I think by that you can save about 0.98 ton per year. And building our houses, we tropical countries, we want our house a good cross ventilation, good sunlight to enter. If you build that house in that context, we save up nearly 0.9 tons of carbon footprint. And vegan diet, definitely, if you use it, you save about 0.8 ton of carbon dioxide. 1 kg of vegetarian food produces 1 kg of carbon footprint. Non-vegetarian food contribute about 5 to 35 kg per kg of meat. The red meat is contributing nearly 30 to 35 kg per kg of red meat. So I think whatever it is, encourage vegetarian diet in that one. More fiber, you got more antioxidant, low fat, low sugar, low salt, and eat 10% is what you are going to eat so that your weight also can reduce. And heat pump, use it, LED lights. By that time, you've been said 0.795 tons per year. And improve the cooking equipment using a appropriate vessel for cooking, and also the defreezing your refrigerator. And also when you're cooking, if you see a blue flame, that means energy being utilized properly. If you see a yellow flame, that means your cooking coil has not been, food particle might have dropped there. You have to maintain cleanliness so that for a better energy utilization. And by that you can save about near 0.64 okay. You can save nearly 0.8 ton. Now the renewable based energy, because agriculture farm we have been doing, all the villages, they have the cows. When they don't yield the milk, later on also they're beneficial. Their dung cake produces methane gas. We can use gobar gas, biogas for all the areas, for the clean energy will be there for heating purpose in the villages. And even after that, what left behind that methane gas, that can be used for biological farming and all these things. And that definitely reduces the carbon, that 0.64 ton per year. In addition to that, after the death, the skin hide of the cow can be, cattle can be used for the chappals and all this thing. And Common sense and social concern with the technology help the climate change. Here is a lady on the right side. She is a national awardee Padma Shri, Salamarda Timmaka. She don't have any children. She raised the tree, road tree, over 300 of them. Their long lives are there. They give space and life, home for the various birds and animals and all these things. Reduce the air pollution as a matter. This is something great. And this is the 75-year lady in front of her legislative house. In the evening, she sells the corn on the cob and cooking. She uses the solar heating. Look at that. How is her concern? Hats off to this lady. And she has to earn her own living. We have to learn. We have to contribute significantly ourselves. And these are all the natural plants. We can keep it. So there's the natural indoor air purifier. Use that one. As a matter of fact, expose to sunlight once a week, remove the tray of water once a week. And positive signs for clean air and climate change. Before conclude, National Mission for Clean Air. Our Prime Minister has assured clean air for everyone in India by 25th August 2020, he promised. He has want to reduce the suspended particulate matter by 35 to 50% between 2025-26, zero land degradation by 2030, and he 26 million hectares of degraded of land to be restored. That's what our Prime Minister has taken positive way in that one. In addition to WHO, NGO, climate change, where I am a signatory, various professional organizations have signed, and also the various other countries contributed significantly to protect the health. And nature taught us the COVID period, pandemic, we had lockdown period. During that time, we could be able to see 100 away the snow peak mountains of the Kanchenjunga, Calcutta area, and we can see the blue sky first time. Lesson what we learned during the pandemic need to be persuaded, propagated, and practiced based on science and to save our planet Earth from the pollution from all the stakeholders. Ladies and gentlemen, thank you for your time, patient hearing. A healthy breath will always bring healthy life. Let each one teach one and plant one tree and maintain it. It gives free oxygen for 4 people per year. I think we can and we will overcome the air pollution, global climate change with all the stakeholders, put our heart and mind together. This is an emergency situation. Let's work for it. Thank you for your hearing again.
Thank you so much, Dr. Paramesh.
Yes,
We have 5 minutes for taking any questions from the audience. And
yes,
we have received one question in the chat so far from Shib Sankar Pale, I think. Would you like me to read this question out loud, sir?
please, please.
So he asks if dust in the air is the main cause of most health damage, or can other sources of air pollution also be a major component of health damage? That's his first question. And then the second question is, yes, please go ahead.
Well, I think all various components will be there. The air, I see indoor air pollution has got aerobiologicals, dust mite, pet dander, and cockroach and fungus, all these things will be there. And irritants along with the cooking, non-commercial cooking fuel, various chemicals will be there. And the pollens, aerobiologicals in the outside, they are 7.5% is the cause for it. And if they are deposited with the diesel particle, they're 50 times more allergenic. So even the plants in urban areas, much we are cutting the trees, but they are more potent pollens they are produced. And particulate matter deposited, they will produce definitely allergic disease. But the one without any aerobiological produce allergic diseases. Other chemicals can, as an irritant, produce the irritation of the airways and wheezing and all this thing. In addition to that, they will change the 2.5 micron, change the genetic pattern also. So if you're non-atopic, you're not inherited from the family, it will change your genetic pattern. You become inherited. That your children, your grandchildren suffer in future. Yes.
So the second part of his question is, how does air pollution affect spinal health?
Spinal health, as I said, air pollution, it produces airway narrowing. Airway narrowing, what happens? You have obstructive airway disease. When obstructive airway disease, you have problem getting the air out. You can get the air in and asthma. That's why I mentioned your shoulder will go up, your turtleneck, and if the angulation will come there, you hunch back. That's why the children, we have also brought a legislation avoiding children carrying the heavy bag that makes them worse. So it should not be more than 10% of their body weight. Because of that one, it came there. So that is the spinal problem produces from the airway obstruction, turtleneck and obstructive airway diseases, barrel chest. Yes.
Okay, sir, thank you. I think that's all for now for questions. Further questions can be taken in at the end of the third talk of today's session, where we have a discussion, a few minutes dedicated for discussion. Thank you so much, Dr. Paramesh, for accepting to give a talk. And yes, thank you so much. I'll be introducing the next speaker for the day, who has joined us all the way from Kazakhstan. Dr. Aymgul, am I pronouncing your name correctly? Oh. Yes.
Yes, hello.
Yes, we can hear you. Oh. Yes, can you hear me?
Yes, I can hear you. Should I start?
Yes, but before you start, I'd like to introduce you to our audience for the day. So that's Dr. Aymgul Kerimre. Am I saying that correctly?
Yes.
Great. All right, great. Thank you so much. So Dr. Aymgul has joined us all the way from Kazakhstan today. She has an Masters of Science degree in Environmental and Energy Engineering from Sheffield University in the UK. And she has a PhD in Science and Technology from Nazarbayev University. And she finished her postdoctoral studies in 2021 at the Al Farabi Kazakh National University, where she is currently working in the EU for Energy program, and she's the country expert for Kazakhstan. She's been working as a researcher in various research institutes in Kazakhstan for the last 10 years. And apart from this, she's also worked as a consultant at the International Energy Agency, for the UNDP, the World Bank, on various topics related to air pollution, climate change, and energy transition. Over to you, Dr. Aymgul.
Thanks a lot for introducing me. Let me share my screen.
Yes.
Is it visible?
Yes, yes.
Yeah.
You can just put it on slideshow mode. Yeah, great. Thank you so much.
Sorry, my neighbors are doing some repairment works. A bit noisy here.
No problem.
So I represent Al Farabi Kazakh National University. It is located in Almaty city in Kazakhstan, and today I would like to talk about air quality in the Almaty city, the largest city in Kazakhstan. When we talk about air quality in Kazakhstan cities, during some of the days during the winter time, Kazakh cities are among the worst polluted cities in the world. For example, in the first week of January, Almaty was among the worst, most polluted cities, according to website AQCIN, which provides independent monitoring network of PM 2.5 in the Almaty city. And you can see on the right hand side the screenshot from that website, and the capital city of Kazakhstan, Nur-Sultan, took 7th place in the world according to the air quality index. And why it happens? Why in the winter time there's so much severe air quality degradation? It's because in Kazakhstan, during the winter time, temperature goes below -15, -20 degrees Celsius, and this requires a large amount of heating demand, and households population use solid fuels or natural gas to heat their homes. Also, there are coal-fired power plants, combined heating power plants, which provide not only electricity but also heating for the urban residents of Kazakhstan cities. When we talk about emission sources in the cities of Kazakhstan, majority of emissions, especially particulate matter, comes from coal thermal power plants. And most of the electricity is generated at those plants. 69% of electricity generation in 2019 were coming from coal-fired power plants. And in terms of emission standards for coal power plants, currently in Kazakhstan, the emission standards are very low, very high, I'm sorry. So, for example, compared to Chinese standards for coal-fired power plants, it is almost 10 times higher in Kazakhstan, the level of emissions, permitted emissions for coal-fired power plants for particulate matter. The same for sulfur oxides and nitrogen oxides. And currently there is a need to adopt more stringent emission standards for coal thermal power plants. And as a result of weak environmental regulation, the majority of coal-fired power plants do not have advanced emission treatment systems. For example, electrostatic precipitators, back filters, desulfurization, or neutralization of nitrogen oxides. Here on the bottom, you can see the picture of coal-fired power plants in Temirtau city of Kazakhstan. This is one of the most polluted city of Kazakhstan. Despite having very low amount of population in Temirtau, if I remember correctly, only about 50,000 people live. However, due to heavy industry, metallurgical industries, steel making industries, and coal power plants, this city is heavily polluted. It's also important to know that there is only 18 million population in Kazakhstan, and there is very low population density. However, the air pollution is still a major problem. Another problem is also coal use by households. According to the household survey conducted in 2018, about 30% of households in Kazakhstan use coal, mainly for heating purposes, and they use gas or electricity for cooking purposes. So cooking is not a problem in Kazakhstan. Cooking is mostly using clean fuels. However, the heating is a major concern because for heating there is much more need for energy, and electricity is not mostly afforded by most of the households, because households living in rural areas, low-income households, they cannot afford electricity heating or LPG heating, and they rely on relatively cheap solid fuels, which also creates not only outdoor air pollution but indoor air pollution. However, only few studies, almost no studies exist which quantify indoor air pollution in households of Kazakhstan. There are lots of studies conducted in India, in China, in other countries, but in Kazakhstan, this is very few peer-reviewed literature exists on this topic. So this is the results of the household survey that was conducted in Kazakhstan, and it shows the share of households using different fuels in urban and rural areas. urban on the left side, rural on the right side. And we can see that most of the urban households, they use electricity and natural gas and district heating, while most of the rural households, they use coal and LPG, coal and electricity, coal in combination with firewood. This also demonstrates that rural households suffer from the indoor air pollution. And in urban areas, even though less share than rural areas, but in some cities, this is also a major problem. So today I would like to more discuss about our recent study, which was published in a Science of Total Environment journal. In 2020, we estimated how the COVID-19 related lockdown affected the air quality in Almaty city. In Almaty city, quarantine was announced on March 19, and this has affected traffic congestion in the city, and during some of the days it was not allowed even to move across the city. And COVID-19 lockdown offered us sad but unique opportunity to test how the traffic-free conditions affect the air quality situation. So we used different data sources for PM2.5 for BTEX pollutants. This is benzene, toluene, ethyl benzene, oxylene, carbon monoxide, sulfur dioxide, ozone, nitrogen dioxide, and we also used meteorological data. We used two periods, so-called lockdown period and pre-lockdown period. Pre-lockdown period we assumed to be the days between February 21 to March 18, and lockdown period for the period March 19 and April 14. And this lockdown period was followed by increase of the temperature compared to the pre-lockdown period. Because as I said, in Almaty city, the temperature decreases during the winter time substantially, and during the springtime it gradually increases. So it affects the it affects also the air quality in the city, because the higher the temperature is, the less fuel is needed for heating, not only by the households, but also at the combined heated power plants. And this graph shows the PM2.5 concentration for the period of February 21st to April 14th. And the red line shows the lockdown period, the beginning of the lockdown period in March 19. And what we have observed here is that the PM2.5 concentration has a declining trend annually, not only in 2020, but here the blue line is 2018, orange line is 2019, and PM2.5 concentration reduces annually from February to April. That is related to the increasing the temperature and possibly the reduction of temperature inversions. Also important to know that Almaty is located in the foothills of the mountains, and there is also temperature inversions more frequently in winter time, which prevents the dispersion of the pollutants and contributes to the air quality deterioration. But in this study, we didn't account for temperature inversions because of the unavailability of such data. So we had only made some discussion and notes that this could be also a significant factor. And To exclude this seasonality effect that every year from February to April, there is a declining trend of PM2.5, we compared the lockdown period from 19 March to April 13 with the previous years, the same period with the previous years, to exclude this seasonality effect. And what we have found is that there was a reduction of PM2.5 compared to the same periods in the previous years by 18 to 23%. However, the air quality was still far from being clean, because for 18 days during the lockdown, the WHO limits for air quality were exceeded. At that time, the WHO limits was 25 microgram per meter cube, but currently it changed. But here I present the previous air quality standards. Now it exceeds the WHO limits to a much more extent. So despite the lockdown, when there was almost no traffic outside, the air quality was not clean. Also, there was some reduction by 20%, nearly by 20%. And there were spatial differences. Here on the map, you can see on the left side the daily concentrations for the period from February to April, and on the right side in 2020. And compared to the previous years, there was a reduction, and with substantial spatial differences. For example, there was a significant reduction in the northern parts of the city, and lower reduction in the southern parts of the city. And in general, the northern parts are more polluted compared to the southern parts of the city. The mountains are located in southern parts, and the coal power plants are located in the northern part. So we assume that significant contribution to the air quality deterioration by coal-fired power plants, which are located on the north. And within this study, we measured benzene, toluene, ethylbenzene, oxylene concentrations, so-called BTEX concentrations in Almaty, and we have found that during the lockdown, some of the pollutants were even higher than the previous years. For example, benzene and toluene were 3 and 2 times higher than the average in 2015-2019, while ethylbenzene and oxylene were lower compared to the previous years. Possible reasons could be that during the lockdown there could be more burning of coal residential houses or bath houses, so-called saunas. But of course, more studies are needed to quantify the reason of such situation. We also compared the toluene to benzene ratios. According to the previous literature, if toluene to benzene ratios are more than 1, these are general vehicle emissions. If this ratio is less than 1, these are general coal combustion. And we have found that during the 2020, during the lockdown period, most of this ratio was below 1, which indicates the significant contribution of coal combustion rather than vehicle emissions. For other pollutants like nitrogen dioxide, sulfur dioxide, carbon monoxide, and ozone, there was a varying effect of the lockdown. For example, for nitrogen dioxide and carbon dioxide, there was a substantial reduction by 35%, 49%, but there was a statistically insignificant increase in sulfur dioxide and increase in ozone concentrations during the lockdown compared to the pre-lockdown period. So going to the conclusions, annually due to increasing the temperature, outside temperature, there is a reduction of fuel use by coal-fired power plants, by households needed for heating, and this results to reduction of emissions. So this period from February to April is general declining trend of emissions and pollutant concentrations. So to exclude this seasonality effect, we have to compare the same period of the lockdown with the previous years. And, and lockdown affected different pollutants in different ways. For example, if there was a reduction of PM 2.5 by average 21% compared to the previous years, the air quality still was not considered to be clean because most of the days WHO standards were exceeded. And for benzene and toluene, even during the lockdown, the concentration were even higher than previous years by 3 and 2 times. And ethyl benzene and oxylene were lower, and there was a reduction of carbon monoxide and nitrogen dioxide substantial. And in general, this is in line with the previous literature, which shows that lockdown has more effect on vehicle-related emissions like carbon monoxide, nitrogen dioxide, while other coal combustion-related emissions, there was a reduction to a low extent or even increase, like in the case of sulfur dioxide. We know that sulfur dioxide is mostly coming from coal combustion or industrial emissions. So in the case of Almaty, sulfur dioxide was even increasing during the lockdown period, which also confirms that sulfur dioxide comes from coal combustion, because during the lockdown, the coal-fired power plant continued its operation, while there was mostly effect of the lockdown on the transport. And we concluded that non-traffic related emissions substantially deteriorate air quality in Almaty city. We have also conducted a similar study for Ust-Kamenogorsk city. It is published in Aerosol and Air Quality Research Journal. I'm not going to talk about this paper today, but I'm just wanted to mention that if you want to learn more about other cities of Kazakhstan, we have another publications. So this is the industrial city Ust-Kamenogorsk, which is located in the eastern part of Kazakhstan. And we have conducted also similar study. Thanks a lot. If I understand, we have a questions session later, right? Thanks.
Thank you, Dr. Engul. We can take a few questions now, but we can also take questions in later. So if anybody has any questions to ask, please feel free to drop them in the chat box. If not now, then yes, we will also be taking questions at the end of the final talk. So you'll be around, right?
Yes.
Dr. Engul? Yes, all right, great. Thank you so much for your talk. We'll be taking questions at the end. In the meanwhile, allow me to introduce our final speaker of the day. This is Professor Murthy. He is a researcher at the Indian Institute of Tropical Meteorology in Pune. 1 second, sir. I will just introduce you and then you may present. So yes, Dr. B.S. Murthy, he is a Science F and presently the project director of the Metropolitan Air Quality Forecast Program at IITM Pune. His research interests are in air pollution, atmospheric boundary layer and convection, and he has been with IITM for about 25 years and has published more than 50 peer-reviewed research papers. He's also mentored students of various levels and currently is leading the SAFAR MAPAN, is that the correct pronunciation? Air Quality Networks of India. And he's providing air quality forecasts to the metropolitan cities and is deeply involved with various related field campaigns, including continuous profiling of atmospheric boundary layer. He's also part of multiple international collaborations such as Indo-UK, APHH, which is the Air Pollution and Human Health. Thank you so much, Dr. Murthy, for joining us, and over to you.
Good afternoon, everyone. Thank you, Ms. Anupama. And I would like to thank the organizers for giving me an opportunity to deliver a talk on this occasion. Let me share my screen. Anupama, can you see the screen? Hello?
Yes, sir, it's visible.
Okay. So this is the theme is air quality, and the title is Measurement, Prediction, and Mitigation. So this is the work which I'm presenting is from our group, SAFAR and MOPAN group of Indian Institute of Tropical Meteorology, Pune. So the air quality is well known nowadays. Everybody is aware of air quality, and they also experience the harmful effects of air quality. As Dr. Parmesh has mentioned earlier, it will affect each and everyone because we are breathing 24 hours a day, and without which nobody can survive. So the first thing that we want to know about air quality is to know what is the air quality. We need to measure what are the air pollutants in the atmosphere. It's not sufficient to measure at one location. If you want to know about the air quality of a city, we need to have measurements at different representative locations like industrial, residential, commercial, and so many other places characteristic of that particular city. So in air quality, we have two networks. One is SAFAR and MOPAN network. SAFAR means System of Air Quality Forecasting and Weather Research. And the other one is Modeling of Air Pollution and Networking. So SAFAR is meant for a particular city where we have installed 10 air quality monitoring stations, whereas the MOPAN is meant for entire India, where 21 air quality stations are installed at different locations across the length and breadth of India. So to know about the air quality, we know that air quality deteriorates because there are pollutants emitted by various sources. So first we should know what are the sources and how much they are contributing. So that will tell us the emission inventory, emission of pollutants. So next thing, what we want to know is we want to know not only the current air quality, we want to also know what will be the air quality tomorrow and day after tomorrow, for which we need to have a numerical model where we give input of emissions and also the input of meteorological conditions, means present condition of the atmosphere, so that in time it will do iterations, and then through multiple equations and then physical processes in actually it will be able to present what will be the air quality tomorrow. And then once you know the air quality, what is required is health advisory. So this is meant for the common public. We need to tell them what are the things that can be done and which should not be done if air quality deteriorates tomorrow and day after tomorrow. And the last one is the mitigation. Once you know the sources which are majorly contributing to air quality, how to mitigate them. So the outline of the talk is about first the observational network. The second one is emission inventory, to know the magnitude of emissions that are contributing to the air pollution. Then about air quality forecast. How do you forecast? And then the dissemination of the information about air quality to the general public through various media. And then the source apportionment. This is to know which are the sources majorly contributing to air pollution at a particular location, for which we need to have chemical composition of particulate matter measurements. And we also should know the profiles of sources, particular source, what it emits, what it contains, and how much it contains. Once you know these two data sets, we'll be able to tell which source is contributing how much at a particular location through some statistical methods like PMF, positometric factorization, or mass balance equations. And there are issues in the forecast. What are the current issues that people working in air quality research are facing? Then what are the mitigation strategies that can be applied? So this is where IITM's air quality station is located. So this is one observatory where air pollutants are measured. And top of the roof, you can see the MET parameters that measure wind speed, wind direction, temperature, and humidity. And other inlet tubes, this means it sucks air, and then to various analyzers within the observatory, and it measures the pollutants. It's a continuous one, 24/7 it measures. And this is the inner view. Here what we have SO2 monitor, NOx, CO, O3, and particulate matter, PM2.5 and PM10, in smaller as well as bigger particles. Along with this, we are also measuring the radiation as well as meteorological parameters. All this get logged into data logger and then PC, from which it will be sent to a central server located in IITM. So we get information about air quality at 10 stations, all air pollutant concentrations from 4 metropolitan cities continuously. And these are the criteria air pollutants which United Nations has mentioned in their US EPA protocol. So particulate matter of 2.5 and 10 micron size, less than 2.5 and 10 micron, nitrogen dioxide, carbon monoxide, lead, then ozone and sulfur dioxide. And there are two ways to measure. One is the automatic one. It measures continuously. Particulate matter is measured by beta attenuation, SO2 by ultraviolet fluorescence, O3 by ultraviolet photometric, and CO is by infrared spectroscopy, and NO2 by chemiluminescence. And another method is to know the 24-hour accumulated particulate matter, which is a gravimetric method. So here we suck air and then it gets deposited on a filter paper, and we weigh it and then know how much air particulate matters have deposited at the filter paper. Using this filter paper, we can do offline analysis to know what is the content of this particular matter, and by subjecting the filter paper various instruments like atomic absorption spectrometer and chromatography and all. So for a common man to understand the air pollutant concentration, it is put in terms of air quality index. So there are 6 categories. One is good, when PM10 is less than 50 microgram per meter cube, and the air quality index becomes 0 to 50, it's called good air quality. Then it goes to 51 to 100, it's called satisfactory, and 101 to 250 moderate, and higher than that poor, very poor, and severe. Similarly, for PM 2.5 also there are some thresholds. 0 to 30 is considered as good, and then 30 to 60 satisfactory, then 60 to 90 moderate, and 90 to 120 poor. So 120 to 50 is very poor and severe. Similarly, for other gaseous pollutants, also there are some thresholds based on its effect on health. They have been air quality index is computed. And once air quality index of a city, when you say that we calculate the air quality index of each and every criteria pollutant, and the highest of the air quality index of particular pollutant is considered as the air quality index of the entire region. This is our suffer portal in IITM, where you have the schematic diagram of how observational networks are located, the forecasting model, and then where the data goes, and then the quality control is done in IITM. And then the output is sent to various servers for dissemination to the public. This is how it looks. And what you can see is the 4 metropolitan cities, Delhi, Pune, Mumbai, and Ahmedabad. And below what you see is the air quality forecast on 1 to 30 days. So 2 days air quality, what you say is put it in color diagram. Moderate yellow, good for Pune, Mumbai it's good, and above satisfactory. So you can see by changing the cursor to different station, you can see what is the air quality for the next 2 days. In addition to that, we also have location-specific air quality index and air pollutant concentration. If you go to the website, where there you have location-specific air quality, as well as weather parameters, and then the next days what will be the air quality index. And this is another network. It is a MAPAN, modeling of air quality, air pollution modeling and network, where we have about 21 stations spread across India. And these stations, what you are seeing on the map, are what we analyzed this data during the lockdown time to know how air quality has improved during the COVID-19 lockdowns. Here, what you can see is the pre-lockdown air quality index. There are 8 stations: Delhi, Pune, Tezpur, Trivandrum, Jabalpur, Chandni Chowk in Delhi, Goa, and Mahabaleshwar. What you see is the color code will tell you the air quality. Well, it is red is very poor, and yellow is moderate. And the box, there are 4 pollutants like PM 2.5, PM 10, and CO, ozone. So in this, which pollutant is marked, that is the leading pollutant, because that is what is deciding the overall air quality index. If you see for Delhi, what you find is PM 2.5 is the major one, which is always the leading air pollutant. And similarly, as lockdown progresses, the leading pollutant also changes from PM 2.5 to PM 10, and then ozone, sometimes it goes to CO. What you find remarkable in this is Chandni Chowk and Mahabaleshwar. In Mahabaleshwar, what you see is ozone has become the leading air pollutant before lockdown as well as during the lockdown. You can see that the air quality has improved during lockdowns. 4 phases have been mentioned in this lockdown 1, phase 1, 2, 3, and 4. So there is some deterioration during phase 4. And this is about the suffer model by which we are giving the forecast. There are 4 domains. The biggest domain spatial resolution is about 45 kilometers. The next one is 15, next one is 5. And then the lowest domain covering the Delhi area is 1.67 kilometers. Similarly, the same configuration is applied for other 3 cities, Pune, Mumbai, and Ahmedabad. And the forecast is for the next 3 days. And this is the configuration of suffer model. For any model, what is required is the present status of the atmosphere in terms of its weather parameters, as well as chemical constituents. And then what we require further is this should be a two-way interaction. The chemical composition means atmospheric chemical interactions as well as weather parameters. They are interacting with each other in real time. So for Delhi, for these 4 metropolitan cities, what is special in this is the local emission inventory which we have developed goes into the model. Usually the model takes initial values from global models, and then unless which are of low resolution, we need to give the local realistic so there are here what we have used is suffer dynamic gridded emissions for Delhi, Pune, Mumbai, and Ahmedabad. Similarly, we have used the IC from initial and boundary conditions from ANSEP GFS model. And these are various physical processes which are simulated by the model, like chemistry transport model requires transport vertical diffusion and dust transportation. And then there are interactions between the gas to particle conversions, and then aqueous atmospheric chemistry interactions. And there are sink mechanisms like wet deposition and dry deposition, clouds and other things. And then WRF meteorological model involves dynamics, and then subgrid scale parametrizations are required for convection and land surface models. And then radiation and cloud microphysics are also involved. These are the emissions of PM 2.4 at the 4 metropolitan cities, which go into the model. These are the bottom-up approach method emissions of PM 2.5. Not only PM 2.5, other criteria pollutant emission inventory also goes into the model. This is the emission inventory for the 4 metropolitan cities. What you find here is the first topmost one is for Delhi. What you find is for left one is a PM 2.5 emission inventory. The right one is for PM 10. What you find is transport contributes about 41% to the PM 2.5. And the next one comes the wind-blown dust. It's a violet color. And of course, there are industrial emissions. Whereas if you come to PM 10, what is contributing majorly is wind-blown dust. It's bigger particles. Similarly, for Ahmedabad, you can see there is some variation, but mostly the major sources of pollution in any urban city are mainly transport, vehicular transport, and then wind-blown dust, and then industries. This is the verification of forecast for the 3rd day for the entire year. It is a daily mean of 10 observations in a city. And what you find is the line is the model, black line. And then those red dots are from observations. And the background is the maximum and minimum also plotted in this. What you find, there are some deviations, and from season to season it varies. There are uncertainties in the emission inventory as well as a representation of actual physical processes in the atmosphere. All this will play in forecasting. In addition to this, the land use land cover also has to go at a high resolution, because the wind plays a very important role in circulation and direction. Unless they are simulated properly in the model, your prediction can go wrong. And these are correlation diagrams between observations and model. What you find is from 3 seasons we have mentioned, more or less the correlation coefficient goes from 0.6 to 0.7, even 0.86. And seasonally, there are some variations in prediction. And normally the air quality, if it is satisfactory, good and moderate, we are not bothered much. But at times the air quality deteriorates so much that it becomes very poor and very severe. So what is causing this extreme pollution episodes? One thing is that temperature inversions in the atmosphere develop during winter. And during this stable conditions, what happens, whatever the pollutants emitted are getting trapped near to the surface, because above the boundary layer, there will be a strong inversion. Another one is the transport. There are some dust storms. If you consider Delhi to the northwest region, the arid region is there from where dust can get lifted up because of high winds. And depending on the wind direction, usually it is westerly, southwesterly, that will come to Delhi, and then it will cause extreme pollution in Delhi. So there are times that though pollutants are emitted far away, they can contribute to local increase in pollution. Another one is about, as you all know, the biomass burning or crop residue burning. That happens usually in October, November in Punjab and Haryana. So they burn their crop so that they can start a new crop. So that will usually go to higher level, and then because wind direction usually is westerly, so that is brought to Delhi, and then the air pollution there will increase. In addition to that, because of winter inversion conditions, stable atmosphere, the pollution gets trapped for so many days, and then it gets dispersed whenever wind speed is high, and then more radiation is received at the surface. And this is about the low stubble emission, but very high percentage share. So how much fire emissions are contributing to Delhi's air pollution depends not only on the magnitude of emissions, but also the weather, means wind circulation. If emissions are less and wind circulation is favorable, means the winds are the upwind region of Delhi, if winds are westerly, those emissions will be brought to Delhi, and then its contribution to Delhi's air pollution is high. Suppose there are high emissions, but the wind is not favorable, wind direction is not favorable, and it is going away from Delhi, means southeasterly, then its contribution to Delhi's pollution will be less. This is what you see in the diagram. The left side figure shows the total PM 2.5 emission is 6.48 gigagram per day, and PM 2.5 is 610 microgram in Delhi, and the contribution of Delhi PM 2.5 to PM 2.5 in Delhi by stubble burning is 25%. Whereas the right side figure, what you see is high stubble emissions. As you see, the more area there are fires are there, but its contribution is only 3% to Delhi because the wind direction is just opposite. You can see the circulation pattern derived from the model. What you see is the northwesterly wind direction, which will bring. This is the point where Delhi is located. You can see that winds are favorable. Whatever is emitted to the northwest are brought to Delhi. Whereas here the winds are in just opposite direction, and Delhi is the downwind direction of stubble emission. So that pollution doesn't enter Delhi because the winds will take away from Delhi towards Rajasthan. And this is the share of stubble burning to Delhi's PM 2.5. What you see is from October to November, 16th October to 15th November in 2018 and 2019. You can see that contribution changes from as low as 5% to about 44% or 60%, depending on the wind circulation. So what is the current situation, and then what are the issues in simulating air pollution or knowing the air quality on a particular day? So what so far I have shown is the mean air quality in a day. means a mean concentration of air pollutants. But if you want to see the diurnal variation, there will be a lot of mismatch between the model and then the observations. That is due to not a proper representation of a land use pattern as well as urban canopy, multi-storied buildings. These things will create, they become a block for circulation and they create local circulations, then stagnation pockets. So this is what needs to be improved. If you want to further improve the air quality forecast, then other one is improve chemical speciation PM 2.5 simulation and validate the observations. What we are showing is the PM 2.5 total concentration, but we don't know the how the model is simulating the chemical composition of PM 2.5, which majorly consists of ions, organic carbon, black carbon, and other things. So we need to know what is the chemical composition, because when we say the health effects, we are mainly concerned about the size of the particle, but not its chemical composition. But there are some toxins in the atmosphere which should not be there. Even a little one also will affect your health. So it is important to know what is the chemical composition also in addition to the size. And then source apportionment in hotspot areas. In any city, you know the major locations where pollution is high, that we say it is a hotspots areas like traffic junctions, industrial areas, or garbage near to garbage fields, and then and some incineration. So we should know what is the what are the sources in those particular areas, for which what we need is source apportionment, which is more location specific, whereas the emission inventory in general is about the entire Delhi region. So that we usually get either road dust or industries or vehicular traffic. But when you go to a specific area, we come to know what are the unique features of that particular area, like whether metal industries, which metal is more in the atmosphere, or which gases are more in the atmosphere. This can be done if you have the observations of chemical composition of particulate matter. It requires a large data because it is done through statistics, which is mainly data driven. We have done source apportionment of particulate matter in Delhi at 3 locations at Ayanagar, Okla, and Noida. Okla is an industrial area. Noida is a developing area, so much construction is going on. Ayanagar is another area where IMD observatory is there. So, and then how do we know what we are measuring the chemical composition is correct or not? What we need to do is the mass closure. PM 2.5 for 24 hours, how much is there, that we can get from gravimetric analysis through filter paper. And then we can subject the filter paper to know the chemical composition like ions, and then trace elements like chromium, copper, zinc, arsenic, bromine, and then other fine soil, mainly dust, aluminum, silica, calcium, tin, manganese, iron. So from this, we come to know whether if you add the mass concentration of all these chemical components and then compare with the gravimetric PM 2.5. So how much imbalance is there, we come to know. Here we have done 2 campaigns. It's done in December, January, February in Delhi, and for morning, and because there is a diurnal variation in the sources as well as heterogeneity in the spatial variation of sources. So we want to know how the sources are varying day and night. Because daytime there will be more emissions, nighttime there will be less emissions because human activity is less. So we sampled for 8 hours each during night as well as day. And the left side figure, top one, what you see is the microgram per meter cube of elemental carbon and then organic matter, fine soil, trace elements, ions, and remaining imbalances others. Here, what you find on x-axis is the location. Ayanagar during night time, and Ayanagar PM is 10 to 16 hours during daytime. Similarly, Noida nighttime and daytime, Vakla during nighttime and nighttime. What you see is the green one is occupying a major portion, which is ions, mainly chloride, sulfate, ammonium, and nitrate. These are the major components of PM2.5. The next one is organic carbon, and then fine soil means road dust, all elements together. This is how diurnal variation in the chemical composition is there. And if you see the percentage of them in PM2.5, what you find is ions are contributing maximum. Next comes the organic matter. Next comes the elemental carbon. And then trace elements. If you see the correlation between these two, you can find that the correlation is about 0.8. The y-axis is the estimated PM2.5, whereas the x-axis is the gravimetric method, and the y-axis is the addition of all components by mass. And this is the source apportionment result using positometric factorization. For Noida, what you find, the major contribution is from biomass burning. 32.4% is contributed by biomass, and then dust is about 22%, and there are metal industries come about 11%, and then secondary aerosol, mainly these 4 ions, contributing 16%, and then vehicular emission, road traffic 17.8%. And this is maybe different from the emission inventory for the entire Delhi region. This is mainly derived from the statistical method from observations, whereas emission inventory, what is developed from bottom-up approach is knowing the activity data and then the emission factors, you can find the emissions, the total emissions. And this is for Vakla. And here also what you find is biomass burning is 16.9%, and dust is about 7.9%. And metal industries were put into 2 categories, type 1 and type 2. And then there is refuse incineration also is there, about 18. This is mainly from a garbage fill, which usually emits because someone or other will set fire to it. And then there is secondary aerosol, and then this is vehicular emission 22.8%. And similarly at Ayanagar, what you find is 27% from biomass burning, and vehicular emission is 14.2%. And then incineration is 19.4%. This is from the garbage fill area. And what you find is secondary aerosol is 23.9%. So once you know what are the sources, either from emission inventory or from the source apportionment of a particular locality, what you want to know for mitigation is first you should know what is the major pollutant, which is determining the overall air quality index. So that we need to know. This is the leading a major pollutant in AQI. Then what are the sources and their contribution through source apportionment, and then location-specific minor sources. Since though we know that they are the major sources, but practically it may not be possible to control them. But if you focus on the specific minor sources, and if you can reduce that, also will improve the air quality. And this is about the models and then observations, how the chemical speciation is treated in the model. The left-hand side, what you see is Ayanagar model, first column. The second one is Ayanagar observation. What you find here is this PM2.5 is simulated correctly. But if you go to the chemical composition of PM2.5, the last bars you can see Ayanagar, and Ayanagar M is model. The observations, what you find is 32.9% is from ions, and organic carbon is 13.5%, whereas elemental carbon is 6.5%. Whereas in the model, what you find is the ions are only 21%. So models are underestimating and the ionic contribution and overestimating the organic carbon. It is about 31%. So though PM 2.5 is correct, but the chemical composition represented or simulated by the model, there are a lot of uncertainties. And that comes to the mitigation. As literature says, the mitigation measures are mainly focused on reducing excess of nitrogen in vehicular emissions, and then volatile organic compounds, which both contribute to particulate matter. So this is a schematic diagram. The y-axis is NOx and the x-axis is VOC, and these contours are isoplots of maximum ozone for that particular day. So what you see is, suppose there are two regimes for ozone. Because why ozone is important means sometimes ozone becomes the leading pollutant. But in India, as per observations, most of the time the leading pollutant is particulate matter. Though ozone very rarely becomes a leading pollutant. So we need not bother much about the ozone. Suppose, suppose there are two regimes depending on VOC by NOx ratio. If VOC by NOx ratio is between 10 and 20 or less than 10, what you see is VOC control is more effective. That is called VOC regime. So the mitigation strategy should be aimed at reducing VOC. If VOC by NOx ratio is very high, that is called NOx limited or NOx control. So the mitigation measure should be reducing NOx. Whereas 10 to 20, both are required. VOC or NOx both are to be reduced in order to improve air quality. And the central diagram is what was shown previously. This is the initial NOx y-axis and the initial VOC in the early morning, and the contours are maximum ozone. What you find here, VOC limited, this region is separated by this dotted diagram. And so in VOC limited, if you reduce VOC, the ozone also will reduce. Whereas if you reduce NOx in VOC limited regime, usually in urban areas, the ozone is increasing. So in the mitigation strategy, you are reducing ozone but increasing NOx, which will increase the PM 2.5. Whereas in the NOx limited, if you reduce NOx, then ozone will reduce. But if you reduce VOC, there is no difference in ozone. This is what is observed in mid-latitude in US and Europe. And these four diagrams on around, what you see from observations from Chandni Chowk in Delhi before lockdown, and this is Chandni Chowk in Delhi after lockdown. Similarly, at the bottom, at Goa, what we have seen is before lockdown, this is the pattern. And after, during lockdown, this is the pattern. What you see is the patterns are completely different. So the ozone concentration is quite nonlinear depending on both the NOx and VOCs. There are no specific regimes like NOx limited or VOC limited. As per theory, VOC by NOx is so less than 10. They're all VOC limited only. But increase in ozone is not so high when you reduce NOx, either in VOC limited or NOx limited. So the mitigation strategies, what we are supposed to apply, are different from what US and European nations are applying. Our main concern is the particulate matter, not ozone. Whereas for the particulate matter is not a concern. For the main concern is about the gases like NOx and VOCs. So that is the conclusion. Thank you very much. If there are any questions, please.
Yes. Thank you, Dr. Murthy. That was very informational, and I see a few similarities between your talk and Dr. Aimgul as well, in the sense that you both tried to measure differences in air quality before and after lockdown to see what sort of differences arise. So it's interesting to see the observations that have arisen from your studies. The floor is open for questions from the audience and also for general discussion. Yes. So I invite you all, in case you have any questions or any comments to make, please feel free to open your videos, share your, switch on your videos and also open your mics if you have any questions, or else you may drop them on the chat box as well. I will pin all the speakers so that you can see them. Just a minute. Yes, there we go. I see we've got a few participants joining from different countries here. In case you can just drop in the chat box which country you're from, I'm sure everyone would like to know. But yes, Dr. Aimgul, there was a question for you in the chat. We'll start with you, and then we'll go to Dr. Murthy.
I can see in the chat box. I'll read. How is the Kazakh government responding to the country's air pollution problem? Is there any plan to remove or relocate coal power plants from near the Almaty city? This is a question from the earlier speaker.
Yes, Dr. Aimgul, that's a question for you. Could you answer that, please?
Is it for me?
No, sir. It's for Dr. Aimgul. There's a question for you next. I'll ask that next.
Could you give more insight on the relationship between air pollution, soil, organic matter? Yeah, you see from observations, organic matter occupies majorly in PM 2.5 composition. So organic carbon mainly it comes from fertilizers and other things, I think ammonia, and usually from measurements what you find is more organic carbon than elemental carbon. So it's a very important issue because its contribution to PM 2.5 is almost 50% next to the secondary ions.
Okay, Dr. Murthy, thank you. And Dr. Aimgul, I think you heard the previous question. Could you answer that as well, please?
Yes. Currently, the government of Kazakhstan is planning to switch coal power plant in Almaty to natural gas within 5-7 years period. There are 2 coal-fired power plants. First one will be switched early, and the second one like within 7 years period. Hopefully, we will not have coal combustion in the city.
All right, thank you. Are there any other questions and comments? Yes, Dr. Paramesh, please go ahead.
I'm congratulate Dr. Murthy for a wonderful talk. Congratulations, sir.
Thank you, sir.
Question. So recent WHO guideline as of September end,
yes, sir.
The values of suspended particulate matter to the 40%. Our level little higher than original. How are we going to manage it, sir? It is going to be a problem.
I will tell you one thing.
Yes, sir.
When in the lockdown, when there are no vehicular emissions,
yes,
the minimum vehicular emissions,
yes,
and then all other anthropogenic activity has stopped.
Yeah.
The PM 2.5 levels are quite high. Whatever they mentioned, it is double of that. So it's not possible to come to that level because WHO decides these values mainly by their observations in the UK and Europe and then USA, where gaseous pollutants are the major things, not the particulate matter like road dust.
Yes, sir.
So already see 0 to 30 microgram per meter cube of PM 2.5, we say it is good quality.
Okay, sir.
But they reduce it to 10 or 15, just like what they follow in Switzerland.
Yes, sir.
And India will be under very poor condition throughout the year. You see, if you take China, their values are quite higher than what India we are following, our CPCB norms. We
Yes,
follow
yes.
0 to 30 microgram is good air quality for PM 2.5. Whereas in China, they follow 0 to 60 or 70. They consider it as good. So they tell to the public that their air quality is good because their range is 60 to less than 60. Whereas ours we have put 30. So
30, yes, sir. Yeah.
we say it is moderate or poor.
Yeah, WHO says should reduce to 15.
Okay for them, but for us, the in the absence of all anthropogenic activity, what is the background value? That should be the norm. That we got it in lockdown time. So if you keep that value as the threshold, then above that we say it is air quality is deteriorating.
I think another comment I like to make, sir, that is WHO say they're worried only two things: tobacco smoke and the 2.5 micron. I'll add it ozone, sir. Ozone is has a cumulative effect. Cumulative effect is worst irritant as a matter of fact. So
the ozone is not a concern for us, as I mentioned from our observations.
say secondary production, yes.
It's mainly PM 2.5 what is determining the air quality in India.
Okay.
Ozone is very rare depending on the NOx and VOCs. Very green areas are there, biogenic emissions are there, which interact with the NOx and the solar radiation. Then ozone concentration will increase, means more than the threshold. Then that becomes the lead pollutant. So that way ozone is important. In addition to air quality, in general, ozone is harmful for vegetation as well as human health.
Yes.
Surface ozone. For mitigation strategy, I don't think our focus should be on ozone. Rather, we should concentrate on PM 2.5 and PM 10.
Yes.
So there's a comment from Dr. Mgul. Please, you can just unmute and discuss with Dr. Moti directly. Not a problem at all.
Thanks a lot. That was a wonderful presentation, Dr. Murthy. I also wanted to say that in our institute, we are interested in developing such models for Kazakhstan, WRF CAM models, and we are also interested in making source apportionment studies, and in collaboration with your institutes. We see you have a lot of experience in this area, and I also wanted to ask, maybe you conduct some trainings for foreign researchers on these topics.
Yes, thank you very much. Yes, it's possible anywhere on Earth we can do modeling. Yeah, because the initialization of the model is done from the global models or reanalysis products, and the emissions regarding chemical components, the resolution what you get from global emission inventories is very low, maybe 100 kilometer or 200 kilometer, and that may not be realistic. So if you really want to give a good forecast of air pollution, the input to the model should be as accurate as possible, and it should be realistic, for which we need to have emission inventory in the area and the domain of the model. So to start with, you can run the model, there is no problem, but it may not be very realistic. In the absence of other data, we can do that, there is no problem. And one more thing, to know whether a model is correct or not, the observational network is essential. You see, what is absolute truth is observation. Model is in our hands. If you increase emissions, you will get more pollution. If you decrease emissions, you will get less pollution. And so what you want, you can change in the model input parameters to get what you want. But how do you validate the model output? So the only thing is you should have realistic means accurate continuous observations a particular area, so that we know the climatology also. Then we know how the models are performing, good or bad. So yes, this is possible. You can do that.
All right. Thank you, Dr. Murthy. I think that's all in terms of discussion from the audience. And I thank you again, once again, all the speakers of the first day session of today's Young Scientist meeting. Dr. Parmesh from the Vecha Center for Climate Change, Dr. Embul Kerimre from the Al Farabi Kazakh National University, and Dr. Murthy from the Indian Institute of Tropical Meteorology, Pune. Thank you very much for joining us and sharing your presentations today. Professor Krishnan, would you like to close today's session? Sir, one second.
Unmute.
Yes.
I just wanted to say a few things regarding the last part of this, the interaction between Bandaru Murthy and Anigul, is that if the regional TWAS regional office, if we can do anything, please don't hesitate to write to us. Either from Kazakhstan, they can short visit to make you to Pune, your place, or one of you can go to Kazakhstan to sort out the model problem. We will be in touch with you, or you can get in touch with me how best to do this, because the model has to be adopted to the Kazakh conditions, because there is a hell of a lot of coal there. That is a major polluting problem. Ours is more air pollution problem, and we have similar problems. This is essentially meant what I meant in the CASAREP can do anything to make in the exchange visit possible. We will be happy to do it, either the training facilities that could be envisaged for a short period of time. Apart from that, I particularly thank Dr. Parmesh because I learned quite a bit the medical problem, and I really enjoyed the talk. I know about Kazakh problem and problems, and also I think I personally thank Bandaru Murthy for the insight which you have given, making India model. India is really a big model to have. So I think, I don't know the choice of cities which you had, is there any background for that? Or was it Delhi, of course, as you all know. The Calcutta is said the most polluted city. And we might have to look at Dhaka, I think. That is another city. And Karachi, and of course, few other cities in this area. And so I think I personally take this opportunity to thank Anupama for an excellent arrangement you have made, and I hope you make this upload the YouTube for future purposes, and also for the archiving it, because this is very important that we discussed in 2021, what will be our problems in the next 5 years. We may do that, how we looked at these experiences, sharing. So it is very good to have this. Thank you once again, Anupama. Hope to see you tomorrow also. All of you, please join us in the tomorrow also for the session. You could contribute much more effectively for the next session, the water problem. Because after all, the pollution had to get into water anyway. So we will have problems of that kind. Thank you, Anupama.
Yes, thank you so much, Professor. I'm always happy to help with organizing such events. And like Professor Krishnan suggested, in case there's any request from Dr. Kerimre's university about conducting training programs with IITM, Professor Krishnan would be happy to help with arranging such a training program. So please feel free to get in touch with him. And we'll also be in touch with you from the TWAS as well as from the Vecha Center for future events. Thank you so much once again for your lectures today. And we hope to see you again tomorrow. And thank you to all the participants as well.
Thank you.
Bye. Thank you.